the natural base e. The natural base e, also referred to as the Euler number, is an irrational number approximated to be 2.71, so on and so forth. Now, the first thing I need you to know is that e does not represent a variable. It is actually a number. So when we talk about exponential growth and exponential decay, specifically using base e, there are a couple different things we need to talk about. The function a times e raised to the rx power. That number r, the coefficient of x, is going to determine whether we have an exponential growth or an exponential decay. If r is greater than 0, we will have exponential growth. If r is less than 0, we will have exponential decay. Now, what you need to know also about the natural base e, when we look at that function, it will cross through the point 1, 1. So, again, a couple things to remember. When we're graphing on the calculator, put your parentheses around your exponent. And remember, a is going to stretch or shrink your graph vertically. If the absolute value of a is greater than 1, it's going to be a stretch. And if the absolute value of a is less than 1, it's going to shrink. Now let's go ahead and graph our function. So when you go into y equals in your calculator, we need to find that e button. And it's right here above the ln. So you want to hit second ln, and you'll get e raised to that exponent, and we want to type in that negative 3x. So make sure all of that is in the exponent before you hit graph. And then we can see what our graph looks like. So when we come over here and fill in some of our information, we can see it from the graph, or you can also see it from that r. Since it's negative, we're going to have a decay. Our horizontal asymptote is going to be y equals 0. So we can go ahead and plot our horizontal asymptote. And then as x approaches positive infinity, so take a look at your graph. As we go towards positive infinity, our graph is getting closer and closer to 0. As we follow x towards negative infinity, our graph is going up, so that's going to go up towards positive infinity. Our domain, we have all values towards the left and towards the right, negative to positive infinity. And for our range, the lowest value, it gets closer and closer to 0, but not including, and it'll go up towards positive infinity. For our points, remember, we want to go to our table and take a few nice points. Now here, it's going to be much harder to find good points in our e functions. So we're going to take 0, 1, and then you really just want to approximate. We can take 1 and then 0.05. Like I said, it's going to be really hard to find these points, so really you just want that 1.01, okay? Knowing that this is going to be our point and it's a decay, so we're going to go down this way. Remember, it's just a sketch. I want you to go ahead and pause here and try this one, and then check back with me when you're finished to see if you got it right. So hopefully you typed this in the calculator carefully and you found that it's an exponential growth with the horizontal asymptote of y equals -2. And as x approaches positive infinity, we're going up to positive infinity. As x approaches negative infinity, we're getting closer and closer to -2. So our domain goes negative infinity to positive infinity, and our range goes from -2 up to positive infinity. Don't forget, we don't include the -2 because it's never actually going to reach it. These were the two best points I could find on the calculator, so I just use it to approximate and help me draw the graph. That's it for these notes. I'll see you in class for more practice.